All right, ladies and gentlemen, here we go. This is your second review guide. You guys should each have a copy of that. I also sent it to you on the Remind, so you will have that as a text message. We are looking to factor completely. Remember, the first step is to look for a GCF. In this case, we know A is 1 out here, so we're not going to have a number that's a GCF, and they all don't have an X on it, so basically we have no GCF. So we get straight to the factoring. Guys, I'm going to be going quick because you can always rewind me and rewatch it if you miss something. So we put negative 24 on top. We got that because we took a negative 24 multiplied by 1. We're not just taking that 24 and randomly placing it up. Right, so we got negative 24, we got negative 2. Then you're asking yourself two numbers that multiply to be negative 24 and then combine, adding or subtracting to be negative 2. All right, and if you don't know, like I told you before in class, use your calculator. Take that 24, don't worry about signs at first, and just keep dividing up until you come across two numbers. So those two numbers that I come up with are negative 6 and 4. If you add those together, you would get a negative 2, and if you multiply them, you do get a negative 24. So we just put them in their factored form, and that would be x minus 6, x plus 4. Boom, you're done. Okay, and that's how you factor when there's no 1 or no number outside of 1 in front. So if this was a 2, it would be different. You would have multiplied these two and you would have had a different number on top. And we'll see that. Well, actually, no, we won't. But number 2, we got to look for the GCF. All right, and in this case, we're looking at A, B, and C. Remember I told you you're looking to see if the smaller number can divide into the larger numbers. In this case, it can. So 2 is your GCF. You know you're going to have 3 terms inside. How do you find those? You divide by 2. All right, so 2 divided by 2 is 1. And then your x term just comes down. So we know there's an understood 1 in front of that x squared. 6 divided by 2 is a positive 3. We're not dividing by an x, so that x comes down, and then negative 36 divided by 2 is negative 18. Okay, and so we're there. Now we look, we see we still have a square term inside. There's still 3 terms. We've got to ask ourselves, can we continue to factor? And so let's see. We need two numbers that multiply to be 18 and combine, adding or subtracting to be 3. And in this case, we can. There's a 6 and a negative 3. 6 minus 3 is 3, and 6 times negative 3 is negative 18. And so now we have our factors. Don't forget to bring down your GCF. So we bring the 2 down, and we have an x plus 6, and we have an x minus 3. And there you have it. Let's move on to number 3. Look here, we have 2 different terms. We have a square term there, and then we have a 64 and addition in between. So we have a sum of 2 squares. We can take the square roots to get our factors. And so we have square root of that, square root of that. That gives us x plus 8. Remember, since there's this addition sign there, we have to introduce the imaginary numbers. That's the only way that this works. So, and then, of course, opposite sign, x minus 8i. Done. Okay, moving along to number 4. We're looking for a GCF. In this case, we're trying to see if 8 divides evenly into 50. It does not. So we have to look for the next largest factor that can go into 50. So if you don't know your factors of 8, you can draw yourself a little T-chart here. You have a 1 times 8 is 8. 2 times 4. 3 times nothing is going to get you 8. And then we've already used 4, so we know these are all our factors. We already tried the 8, that didn't work, so we try the 4. If you try that, you'll also realize that that does not work. And then you try 2, and 2 is your GCF. So we put 2 outside. We know we're going to have 2 terms inside. So you divide by 2, divide by 2. 50 divided by 2 is 25, and then the x squared comes down, and then negative 8 divided by 2 is minus 4, or negative 4. So now, again, we have to ask ourselves, are we done? Well, there's a squared term in there, and there's 2 terms. Subtraction in the middle, so that means, are those perfect squares? Yes, they are, so difference of 2 squares. So how do we solve that? We take square root, and then we have our GCF, which is 2, and then you have your 5x, and then you have minus 2, and then, of course, opposite sign, 5x plus 2. You guys did pretty good on the review in class today, so hopefully this is all just refreshing your memory. All right, let's look at number 5. Okay, so we're looking for a GCF. Can 2 divide evenly into 9? It cannot, and the only factors of 2 are 1 and 2, so we know there is no GCF. So we get to factoring. So we have our top here. Remember, you're taking this and you're multiplying by that. So that gives you a 20, and then the B term, or that middle term right there, is always coming down. So again, 2 numbers that multiply to get you to 20, and then add or subtract together to get you a negative 9. And so, again, take that 20 and just divide up. 20 divided by 1, divided by 2, divided by 3, until you come to 2 numbers that look like they can get you to a 9. In this case, it's a 5 and a 4. I need them to add together to be negative 9, so that's negative, that negative. A negative 4 plus a negative 5 is a negative 9, and then a negative 4 times a negative 5 is a positive 20. Remember, a negative times a negative is a positive. All right, so we write our factors. X minus 4, x minus 5. Are we done? No, we're not, because we did have a number out here that we multiplied, so we have to get that back out of there. So what do? We divide by 2. This is where we're going to our bottoms up. Then you look and see if your stuff simplifies. Well, a negative 4 divided by a 2 is a negative 2, so x minus 2. And then does negative 5 over 2 simplify? No, it does not. So that's when you got to go to your bottoms up.
Good afternoon, Hawks and staff.
Here's an announcement.
Teachers,
I'm going to
this is not
pause.
a dismissal.
Okay. I took it off the speakerphone, so you guys can't hear the announcement that well anymore. But anyways, so again, that did not simplify, and so we can't leave that on the bottom. We go bottoms up, and that leaves us with our leading 2, x minus 5. We are done. All right. I'm not going to do number 6 because number 6 is just like number 5. You take it through the exact same process. So let's look at number 7. Pretty sure I have number 7 on the next page, and I do. So number 7, this is grouping, factor by grouping. Remember, there's 4 terms. You're going to put the first 2 in parentheses and the second 2 in parentheses. Now we're looking for our GCF. Well, there is no number here, and so we're not going to have a number out, but we do have 2 x variables. Remember, the one with the smallest exponent comes out as the GCF. So x squared. And we want to figure out what goes inside, so we divide by that GCF. Divide by x squared, divide by x squared. Well, remember, when you're doing this, you're subtracting the exponents. So 3 minus 2 is 1, so you'll bring down a single x with an exponent of an understood 1. And then a negative 2 divided by this understood 1 there is negative 2, and then a 2 subtracted by a 2, it eliminates your x values, so you have x minus 2. Okay, so in grouping, you know this is supposed to work out to also be x minus 2. And so you ask yourself, what do you have to multiply an x by to get a negative 9x? Okay, and that should be multiplied by negative 9. Okay, so that is a negative 9 out front. Now, in grouping, you take what's outside the parentheses and you put them together as one set of parentheses, x squared minus 9, and then you take the other set and you just throw those, or you just combine that or turn it into one set of parentheses. You guys remember that. So x minus 2. And then you look at this. Can I factor this any further? No, I can't. There's not even a squared term in there. Can I factor this? Yes, looks a lot like difference of 2 squares, doesn't it? So you have a squared term there, and that is a perfect square. So now you square root of that, square root of that, and then I'll go this way. That's going to be x plus 3, x minus 3, and then I still have that x minus 2. And that is your answer. Let's look at number 8 because that is different. This is a sum of 2 squares. I think we did one on the other page, but let's do this again. Is there a GCF? Does 9 go evenly into 100? No, it does not. Then you break down your factors. Only other factors are 3 and 3. Does 3 go into 100? No, it does not. And so I have a perfect square there. I have a perfect square there, and an addition there. So that's sum of 2 squares. Sum of 2 squares, do it just like difference of 2 squares. Square root of that, square root of that. You got 3x plus 10. That's a sum, so that's an I there. Close your parentheses. And then 3x minus 10i. Boom. And we are done with that. We have also a difference of 2 squares at number 9. So yeah, I'll go ahead and do that. So difference of 2 squares at number 9, look for a GCF. In this case, there is not a GCF. Those are 2 perfect squares. 16 is a perfect square. Obviously, x squared is a perfect squared, and then 121 is a perfect squared. I'll have a list of perfect squares tomorrow for the test. But how do we do this? Square root of that, square root of that. That gives you 4x minus 11. No I because that started off right here with the subtraction in the middle. And then you have 4x plus I. That's it. All right. Number 10. Remember, I want you to show your work, but you can also put the i's in the calculator. When you have a subtraction sign there, that's like a -1 being right there, that you're going to distribute in to each one of these terms. Or it's like saying, like I told you before, you're changing the sign of each term that's inside the parentheses. And so a -1 times 11 is -11. And then we know this is going to be a positive 8i. Then bring down. You kept this the same. And now we're just looking for like terms. Well, there's one and there's one. A 4i and plus an 8i is a 12i. Remember, you want I to be the last term in there. And then you have a 14 and a -11. That becomes a 3. And that's plus. So there you are done with that. Can't go down any further than that. Let's look at simplifying down there, number 11. So on a number 11, you are multiplying. So you distribute. So you distribute that to there. That is 15. Take that, multiply there, and that is, what is that? Plus 21i. Take that, multiply it there, minus 30i. And then multiply that, you have a minus 42i squared. Remember, I times I is I squared. Now we know that I squared means change this sign, change the number in front to a positive number, because I squared is the same thing as a -1. So -1 times -42 makes it a positive 42. So we're just changing the sign. Then we combine like terms. You got a positive 21i minus 30i, and that gives you minus 9i. And then you just bring down your 15. You still have more like terms of 15 and a 42. So that turns into 57 minus 9i. All done. For number 12, this squared term means take the parentheses and multiply it by itself. So that would be the same thing as 3 minus 6i times 3 minus 6i. And then you're doing it exactly how you just did number 11. So I'm not going to walk through that one. All right, continuing along, guys, for number 13. Number 13 is dividing complex numbers. So you want to start by finding the conjugate. Conjugate in this case is taking the bottom and inserting a opposite sign in there, and that would be your conjugate. You have 5 minus I, and you're going to multiply the top and the bottom by 5 minus I. Let's start by just looking at the top. You got 3 times 5 is 15. 3 times negative I is negative 3I. Negative 2I times 5 is minus 10I. And then negative 2 times negative I is positive 2I squared. So now, again, that's only the top. And so let's simplify that top just a little bit. So remember, this I squared means change the sign of that 2 in front of it. So that becomes a minus 2. Then we have this that we combine. A negative 10i and a negative 3i becomes negative 13i. And then I just have my 15 there. Still have more like terms right there. So I have a 15 minus 2 is 13 minus 13i. And that's on the top. All right. Now we still have to look at the bottom. So let's work on that. So we have the top, which is right here. We know that's the top of our fraction. Let's do the bottom. We have 5 times 5 is 25. 5 times I is negative 5i. I times 5 is positive 5i. And then I times a negative I is a negative I squared, or a negative 1i squared. Okay, so if you're doing this right, your I term should cancel out. But let's start by looking at the end here like we always do. So that is an I squared. That's a negative 1, which means change the sign to a, let's change our ink color here. Excuse me. I'm going to change that to a positive 1. You have this, a negative 5i and a positive 5i. That cancels out. And then you bring your 25 down. 25 plus 1 is 26. So 26 goes on the bottom. So, are we done? We are not done because we have to split it. And we're running out of room here. So I'll write this part in green. So this is equal to 13 over 26 minus a 13i over 26. So, does 13 over 26 simplify? Punch it in your calculator and see what you get. It does. And so that becomes, that 13 over 26 becomes a 1/2. Equal to 1/2. And then, obviously, the other 13 over 26 also becomes a 1i because it simplifies to 1/2. And this is your final answer. Guys, there is a lot to that. If you punch that in your calculator to begin with, it will simplify it for you so you can check your work to make sure you're right. All right, let's look at number 14. So when there is not a real term with it, you can't find the conjugate, and so you'll just simply multiply by I. Multiply by I. So 4 times I is 4i. Notice I did not take into account this negative sign. We'll do that at the very end. And so I'll put this in parentheses. And then we know we have a negative sign out here. So you have a 5i times a I. That becomes 5i squared. And once we do that, we know that the bottom turns, we have to change the sign of that, so that should become a negative 5 down there. And then the 4i is still on top. And then you have your negative out. So now you distribute that negative in there, and it's already a negative fraction, so that turns it into a positive 4i over 5. That's your final answer. Remember, again, you can put that in your calculator and it will help you determine what the right answer is. That's the pi key. Hit the pi key 3 times and it'll input your I. And moving along, we're on the back now. I feel like you guys know this stuff pretty good. Remember, the assumption is there are arrows on the end of the lines unless there's points. And of course that means these continue on forever. Okay. So first, saying for the following graph, find the domain range, intervals of increase and decrease, the extrema, which remember that means the minimum or the maximum. You want to find your y-intercept, your roots, which is the same thing as your x-intercepts, solutions, etc. Then you want the axis of symmetry, and then end behavior. So let's look at domain. Okay, first, how far left is it going? This is an arrow, so it's going left forever, and it's going right forever. So we know we have negative infinity to positive infinity. We can't pinpoint where that stops, so we know those are parentheses on there. Then range is how far down is it going? In this case, it's going down forever to infinity, so it's negative infinity. And then it's going up to only right here. And so as you can see, let's undo that. This is the highest point, and that highest point on the x-axis or the y-axis is 7. So from negative infinity to 7, and we do put a bracket on that because it stops exactly at 7. We know it's not going anywhere beyond that. So your interval of increasing and decreasing, that we're doing next here. Remember, you draw your x-axis on the bottom. Again, you know this side is negative infinity, this side is positive infinity. Then you draw your axis of symmetry that's coming straight through right here at 3, a positive 3. And so if you start here and you start walking up, you would be going uphill, so you would be increasing. And then once you get to the top here, you stop increasing and you'll start decreasing, going downhill. So this would be decreasing. And so from negative infinity to 3, you're increasing. And from 3 to infinity, you're decreasing. And so we just write that out. So we're increasing from negative infinity to 3. And then from 3 to infinity, we're decreasing. Your extrema, we already marked that right here, and that's at 3 on x and 7 on y. So 3, 7 is your extrema, and that is going to be a maximum. Y-intercept, where does it cross through the y-axis? Right there. So we'll put our point, and that point is at 0 on x and -2 on y. Remember, if you're looking at a y-intercept, your x value is always going to be 0. If you're looking at the x-intercept, which is also known as roots, then it'll be a 0 on y instead. And so where are your x-intercepts? You have one right here, and you have one right there. Well, that one's not exact, so we'll put a point here, and we'll say that's right in the middle of 1 and 2, and we'll say this one is right in the middle of 5 and 6. And so technically it's like, where are we? We have this one is at about a half and then 0 on y. So about 1/2. Hopefully you won't see any funky ones like this on the test. And then 0 on y. And then you have another one here, which is at about 5.5 and 0. So we have 5.5 and 0. Axis of symmetry is going straight through x at 3. So x is equal to 3. And then your in behavior, which is this here, as you're traveling on x to infinity. So I'm on x here, and I'm going to infinity. What's going to happen? I'm going to start going down to negative infinity. So I'll go to negative infinity here. So all that's asking is, as you're traveling on x to infinity, f of x or y is going down to negative infinity. When you're traveling to negative infinity, so I'll go back up here, I'm traveling on x towards negative infinity. When I hit the line, what's going to happen? I'm going to go downhill. Remember, we're dealing with quadratics, so it should match the in behavior, because you're always going to have these going in the exact same direction on a parabola or a quadratic. Okay, let's move along to number 16. So on number 16, it's saying to sketch a graph with the following characteristics. So first, it says an extrema. You know, that's a minimum or a maximum. And it says the extrema is at 1 on x and -2 on y. So let's plot that point. There's your point. I'd venture to say that's probably going to be going, it's probably going to be taking this shape, since that point is down there. And like I told you guys in class, but you never know. You never know, because that point is still kind of up near the origin, so you never know. But let's see if my theory is correct. So they're giving us the increasing and the decreasing. So let's see how that works out. Remember, I told you when they're giving you that, you want to draw your x-axis at the bottom. You want to draw your axis of symmetry. And you see that's going directly through 1. So we put a 1 right here, because that's where the axis of symmetry is on the x-axis. And then it's saying you're increasing from 1 to infinity. So here. So from 1 going this way to infinity, you're going up. So as you go this way, you need to be going up. So it's just a rough sketch, so we know we're coming up like this. And then it says you're decreasing from negative infinity towards 1. So that means I am decreasing going down to 1. And that's your rough sketch. Pretty much no really easy way to explain that, but Hopefully you understood that. So from negative infinity to 1, it is decreasing, as you can see there. And then, because we're looking from left to right. And then when you get here, it says from 1 going towards infinity, you're increasing, and you can see you're going up. All right, let's do the last one down there, guys. So extrema, we know that's the minimum or maximums, and we know it's at 3 and 2. Again, guys, based on where that point is, I'm thinking that I'm probably going to take a shape like this. And it's telling us we have x intercepts or roots down here, so we know it's going to have to come down this way. So we have one at 1, 0 and one at 5, 0. So you can see in order to make our U shape, we have to do that kind of. And there's a rough sketch for you. So just use what you know and kind of just work your way there. All right, I'm about to send this out to you guys, so hopefully you're still up, because I had open house and I couldn't get all the video done before school, so I had to do the last part after school. All right. Text me if you have any questions.